The deposition system begins now with applying high voltage to the gun. Ensure that all of the interlocks are available, and that includes the airflow, the vacuum tank is actually down, and the vacuum gauge is interlocked to ensure that the vacuum is low enough for the system to start. Turn on the system and apply high voltage first. Approximately 8,000 volts is now applied to the gun. This is adjustable. However, adjusting the high voltage adjusts the arc of the electrons. So too high a voltage or too low a voltage will result in the electrons not hitting the center of the crucible. It's important that you adjust the high voltage accordingly, and once it's adjusted to match the magnetic field, you leave it alone. The actual deposition is controlled by controlling the filament current. We start the filament with 0 and slowly increase the filament current until a beam appears on top of the crucible. Once that beam appears on top of the crucible, it'll begin to melt the material inside. At that point, we adjust the XY sweep underneath in order to center it on top of the crucible, and then we control our deposition rate using the emission control right here. Here we see the electron beam striking a crucible of magnesium fluoride. Using the XY scanner, we can set both the position and the size of the beam to strike the center of this crucible. For example, we can adjust the size in this direction or make it wider, in which case we're now clipping the edges of the crucible and spilling over onto the hearth. It's important that the electron beam be restricted to inside the crucible. So we adjust the size in the X direction. We do the same now in the Y direction. Notice how the beam is too big. It's actually spilling over the crucible right now and hitting the hearth on the front. So I'll make the beam a little bit smaller in the Y direction, confining it now to that crucible. Finally, we adjust the position. Too far to the right, too far to the left, just right in the center. And we'll do the same with the Y. Too far to the back, too far to the front. We'll adjust it right dead center of the crucible. And now that it's centered, of course, we can now increase the current of the beam safely. If you increase the current too much while aligning it, it'll generally speaking either damage the hearth or oftentimes trip a safety system designed to keep the hearth from being damaged. Increasing the current now has the effect of actually melting the material by direct electron impact. Soon the magnesium fluoride won't appear white, it'll actually appear completely molten, as the electrons striking it heat it to a very hot temperature. Deposition can now occur by opening the shutter, controlling the deposition rate via the electron current, and then closing the shutter when done. With the electron beam now hitting the crucible and heating up the material inside, it's time to begin our deposition. We increase the current to the source until the source is glowing orange, at which point we can rest assured that our material is now melted and deposition could proceed. Like any other type of deposition, zero the meter and open the shutter to begin. Now simply increase the heat of the source until we get the desired rate. If the rate's too high, turn it down. If the rate's too low, turn it up. Our target deposition in this case is 900 angstroms. As I approach my target value, it's prudent to turn down the emission current to slow the rate so I don't accidentally overrun. Of course, the crucible cools down very slowly because it's quite hot right now. And close the shutter. $898. The target was 900. At this point, we turn off the filament. However, leave the high voltage applied. We wait until the crucible cools. Visibly, it's still glowing orange. It takes about a minute to cool, and then we can select a new target material using the turret. We go to our new target material and we proceed all over again. We select our new target material by simply turning the source selector. And of course, as we select our new material, a motor turns the plate inside the gun to put the correct crucible in the path of the electrons. Our second deposition layer can now begin by first selecting the film number that corresponds with the crucible we're using. In this case, film number 3, which corresponds to ZNS. As usual, we'll zero the meter just before we deposit that layer. Deposition now occurs the exact same way as the previous layer, by increasing the emission current gradually, opening the shutter, controlling the rate using that emission current, and then closing the shutter to stop the deposition. When we're done our deposition, we first turn off the filament and then turn off the high voltage. For safety, turn the key switch to off and remove it. Now close the gate valve, which effectively isolates the cryopump from the chamber. Finally, we have to vent the chamber to atmosphere. We do this with dry nitrogen. Notice the chamber pressure coming back up. It'll take a few minutes. The chamber will now fill with dry nitrogen, and we'll be able to raise it to remove our substrates. With the chamber venting complete, we can now raise the chamber to remove our substrates. Having opened the chamber, it's tempting to simply jump right in and remove your substrates. However, there's one important thing that has to be done first, and that is grounding the electrical system for safety. Never, ever, ever trust an eBeam supply not to kill you. These things operate at 13,000 volts at 1 amp. It will fry anything. The safe way to do this is to use the grounding strap and touch these electrodes right here that go to the filament. Generally speaking, nothing should happen. But in the event that the safety system of the eBeam gun failed to discharge the capacitors inside, you'd get a very loud arc, but you would live to tell about it. Don't forget this rule. It is not optional. Once again, always discharge before sticking your hands inside the chamber.